Hello, I'm a Cactos person. Jussi Pyörre, CTO at Cactos. Wouldn't consider myself a data scientist, but rather a uh, fan club member of data scientists. So some people have said that I'm really good at making them believe that I would know more about data science than I actually know. Anyway, thanks for the organizers for giving us a chance to come here. And one thing to mention right away, this is not our office. As you may have guessed, our office is in Vallila. The problem with Vallila office is that we are pretty crowded there. We are almost sitting on each other's lap at the moment. We're going to move to the next office soon, but it's not the place where we want to organize any events at the moment. So we're going to, perhaps in the future, then once we have a new office, then organize an event there. Anyway, just before we get anywhere, prior to this event, how many of you had heard about Cactos? Surprisingly many hands. Second question, how many of you believe that we are manufacturing battery storages out of used Tesla batteries? Some are raising hands. So here's some other company doing that. No, it was us. It was you. Okay. Yeah, here's one of the founders, and then there are some Tesla Model S modules connected together and put in a rack. That's our first battery storage that we've done in the early days. But we've come a long way since, so nowadays this product doesn't exist anymore. We are now doing the stuff from new components, unfortunately, because sourcing used Tesla Model S batteries turns out to be more expensive and also more challenging than using new batteries. So we are using nowadays lithium iron phosphate batteries. You will hear more about those in the future on the next talk. So here are a couple of photos from the storage units we've done since. None of these are having any Tesla batteries anymore in them. The big picture there is our grid scale storage, 5 megawatts and 10 megawatt hours of capacity. And then on the left-hand side, there are a couple of smaller units. The up one is something you install inside, and then the two lower ones are units you install outside. And of the last one you can see at the bottom, that's a rendering. So it's a unit we are now working on. It already runs at our factory, but it's not yet in production. So Cactos in numbers, founded 2021, late 2021, so we're a pretty new company. We are just checking the clock that I'm not going to talk over time. So a bit over 4 years old, 10 persons already. We have a factory in Kempele, so in northern Finland. There's a story behind that, but I don't have time for that. And then we have software development, administration, sales in Helsinki. And there are some numbers, how much we've installed and where. So we are already active in not only in Finland, but also in Sweden, Netherlands, and in Ukraine. There are also some of our units. Some industries where we work: logistics, manufacturing, agriculture, real estate investments, housing companies, commerce and public properties. Maybe not going too much into the use cases, but there are many use cases for batteries. We'll talk more about how batteries are being used and what sort of things they do. But I will tell you in essence what the whole point here is, why you actually need batteries. So this is a thing which I love about electricity. I don't think there's anything where there's an abstraction on something that human has achieved, which is on such level that it is in electricity. So how much do you need to know what comes out of that plug? Just take it, you plug it in, and it works. And one would think that it's, things which happen behind that plug would be simple. It's been done over 100 years already, but it's not. It used to be simple, but not anymore. So it has become quite a challenge. So here's the annual electricity consumption globally. You can see the trend upwards. Maybe the thing to notice there is that there's a little bit of renewables out there. Hydropower's been there for quite some time, but then other elements, especially solar and wind, are rising.
What are other renewables?
I have no idea.
The same animals.
Yeah, tides, yeah, waves, and then there's this. I just learned that in Japan there's some sort of a ion exchange thing where they take the river water and then there's the sea and then you do some sort of salt thingy there. I don't know.
Chemical?
The geothermal plant in Iceland, they
Most likely, yeah, but southwest. Yeah. Anyway, here's Finland. Notice how little there is renewables there, and notice how much there are renewables in Finland. So I wouldn't count biomass as a renewable. Really, if you could just exclude that, but otherwise, hydropower, wind power, a little bit of solar power as well. So it's a thing which is a big in Finland and of course in the future in other countries as well. So here's a super simplified version of what happens in the electricity production and well, the whole system. So on the left-hand side, this is, by the way, how it used to be in the past. Let's say 30 years ago is already past. We used to have some coal plant or whatnot producing the electricity. You have the transmission lines, you have the distribution network, and then eventually people consume it. The thing about this is that, first of all, the consumption is steady and predictable. It just does the same thing day after day. Looked at the previous day, it's roughly the same. Maybe then, the temperature changes a little bit of change here or there. So you can quite well predict what's happening next. So it's easy to handle the production side. The other thing which makes it easy is that, of course, there's hydropower, which is controllable. You can add more or less by just, raising the hat, what do you call it, the hatch or valve a bit, and then you get more or less. Or then you have a pile of coal behind the plant and then you just put a bit more in and you get more. So it was easy. Now the things have changed. So you brought in the intermittent elements, which are the renewables, which come if they come, if you're lucky. Even, let's say, a wind front arriving 15 minutes late is already a problem because you predicted it would be 15 minutes earlier and then it's not there. So what do? Somebody else needs to kind of fill the gap. And by the way, this thing needs to be all the time in a millisecond level in balance. So 15 minutes is a big thing. The second thing which happens is that the consumption is also changing. The introduction of all sorts of electrified things are making the consumption more unpredictable and unsteady. There's nowadays already problems that EV chargers, for example, during night, even though the electricity itself is cheap, it's cheap because there are no other users. But the distribution network is already suffering from this, that so many people plug their EVs and they charge at night. So it's going to be like at full utilization. There's no room anymore. So the problem with the transmission and distribution lines is that you can only run so much through it. So the maximum power determines how much you can run through. the best would be that you would have an even power throughout the day, but that's not the case. Continuous fluctuations. So what do? You introduce the batteries, and that's what we do. Depending on the part of the system, you introduce different sized batteries. Typically on these three things on the left-hand side, these are so-called grid-scale batteries. So big units installed somewhere in the middle of nowhere. Well, in this case, typically if you have, let's say, solar farm or wind farm, perhaps next to that, utilize the same connection and even out the changes in the production. But then also on other parts, for example, in the distribution network, if you have these congested places, sometimes there's too much consumption, then you can support that with the battery storages by producing a bit of or discharging energy from the batteries and helping out there a bit. But then, of course, the consumption side, this is an interesting thing. So there's a consumption in locally in all places, and that varies quite much. So you can even that out also with the batteries by just installing a battery next to your electricity connection and help there as well. So Cactos is mainly working on the right-hand side on these two things, which are more on the, let's say, the consumption side. Yes.
So who would be the borders is on the consumption side, like a block of houses or shop?
So logistics centers, manufacturing facilities, farms are a big user of batteries. They often have lots of solar panels, so they want to store the energy. Real estates, yes, some buildings also have batteries and housing companies and others. Logistics is a big thing, and especially in the charging infrastructure, there's plenty of batteries being used because you want to charge the car quickly, and if the connection doesn't allow more charging power, then you can support that with the battery. Going back, this is my last slide. I knew I would be talking too long, so just to give a bit of perspective on what sort of challenges there are from the data science perspective. So this is how the thing runs from up, down. So there are markets where the electricity is being sold and bought. There are these so-called ancillary services. I didn't want to go into that. Perhaps at least Tuomas will talk about that more. So we'll bid the batteries, and we need to know how much money we could make if we decided to bid it to a certain market. Then we need prediction algorithms which would tell how much it would cost, or sorry, how much money you would make if you decided that this battery would help on this sort of a service. We are running fleet of batteries, so all of these batteries are combined or aggregated together to produce a distributed energy storage, like a virtual power plant, as they call it. And that needs to be optimized. So each of them, we kind of distribute commands, who does what, you do this, you do that, in order to produce these services that we have decided to sell. There are predictive models for the sites. We need to know how much electricity they are going to be consuming, because that determines what sort of things we should be doing there. Let's say there's plenty of production at the expensive hours. We may want to supply them electricity from the battery, and we need to make sure that there is electricity in the battery at that moment. So we need predictive models for that. And then the actual energy storage units, we need to optimize those both locally and then on a fleet level. And then the last thing is that the actual batteries, we need to build well, I don't like the term, but the digital twin of the battery, which more or less describes the physics, how the battery works. So what's the state of charge, what the state of health, and so forth. And actually Olli is going to talk about this more and tell how this thing here works. And I guess, Tuomas, yours is going to be more on this end, I would say.
Yeah, sounds perfect.
So many things we need to solve, many unsolved things yet. We haven't solved all of it. We are just scratching the surface. And of course, as the last thing, I want to show you a QR code because we are hiring data scientists. So feel free to scan that, and I'm sure the other presentations will have the same QR code. I went 3 minutes over time. Anyway, thank you. Enjoy the evening.